Hello everybody, today we're going to be doing a trigonometric verification problem. So that's the left hand side, that's the right hand side. The way I would start this is by foiling the left hand side. So basically I'm going to try to make the left hand side fit the right hand side just because I can foil it. I see that all being squared, I want to expand it. So if we expand this thing, on the left hand side we're going to have tangent squared plus 2 tangent cotangent plus cotangent squared, and I'm gonna set that equal to the right hand side. I'm not gonna rewrite it, it's a lot to rewrite. If you don't believe this, you could just foil it out yourself, pause the video and check. Now what can we do? Well, on the right hand side we have secant squareds and cosecant squareds. On the left hand side we have a bunch of tangents and cotangents, right? So what translates tangent to secant? Well, that's where these identities will come helpful. 1 plus tangent squared is equal to secant squared. What about cotangent? Oh, this identity, 1 plus cotangent squared is equal to cosecant squared. Now, I have tangent, I have cotangent, I need them. So I'm going to manipulate these Pythagorean identities. Tangent squared will now be equal to secant squared minus 1. I'm just subtracting 1 from both sides. This is an equation, that's totally fine. And cotangent squared is equal to cosecant squared minus 1. Boom. So there we go. I'm going to put parentheses around them. Kind of makes it easier to see, I feel like. So there's tangent. I don't want tangent anymore. I want secant squared. Here's cotangent. Actually, cotangent's up here. I want cosecant minus 1. Alright, so let's rewrite these things. Instead of tangent squared, I'm going to plug in secant squared minus 1 plus 2 tangent cotangent plus cosecant squared minus 1, and that is equal to the right hand side, which again I'm not going to rewrite, it is so much. Now I'm just gonna kind of combine like terms here, right? So this is what it'll look like: secant squared plus cosecant squared plus 2 tangent cotangent, don't forget, minus 2. That's equal to the right hand side. Now look at this, it's becoming very identical to cosecant squared plus secant squared. Look at that, we have cosecant squared plus secant squared. If only this could somehow equal 0, right? So let's think about what would make this 0. If it was 2 minus 2, but it's not 2 minus 2, it's 2 tangent cotangent minus 2. Alright, what can we do about this thing? Do I want to rewrite the right hand side, maybe play with both sides of the equation to make them look similar? No, I'm going to do this. Now recall that tangent is sine over cosine, and then recall that cotangent is cosine over sine. These trigonometric identity problems can really kill you if you don't know your trig identities. It's going to be very hard to verify these things. I remember in Precalculus, this was like one of the hardest topics we went over. So going forward now, alright, let's see what's happening here. We have this being multiplied against this times 2. Let's write that out real quick. Plus 2 times sine x cosine x times cosine over sine. Oops. Minus 2. And that's all equal to the right hand side. Now let's look here. Sine cancels with sine, cosine cancels with cosine. This really equals 1. So now we have secant squared plus cosecant squared plus 2 times 1, right? Minus 2, which is equal to the right hand side. Now I'm just going to combine like terms. So let's do that real quick. 2 minus 2, that's 0. So I'm going to rewrite the left hand side to be secant squared plus cosecant squared. What is that supposed to be equal to? Well, let's go back up. Oh, well, that's our right hand side, right? So I'm just going to rewrite it. Secant squared plus cosecant squared. And boom, just like that, we've verified both sides of this trigonometric problem, right? Thank you for watching.